Hello everyone, this video is about differentiation. In this video, we will study about the concept of differentiation, the rules of differentiation, and we will understand the rules with the help of a few examples. What is differentiation or differential calculus? So let us consider a quantity y depending on a single variable x and let it be represented by an equation y is equals to fx, which means y is a function of x. If we plot this equation on a graph, this is what we will get. The blue curve represents the equation y is equals to fx. Now, on this curve, we are taking 2 points P and Q, where P is having coordinates xy and Q is having coordinates x plus delta x and y plus delta y. Now, the slope of the line joining P and Q is tan theta is equals to delta y upon delta x. Or can I say y plus delta y minus of y upon x plus delta x minus of x. Let q moves along the curve towards p. Now in this process, both delta y and delta x will decrease and approach 0, although their ratio will not necessarily vanish. If we can plot this, this is what we are talking about. Now, if delta y is approaching 0 and delta x is approaching 0, the line becomes a tangent to the curve at this point P. It means that tan theta approaches the slope m of the tangent at point P, which is given by m is equals to limit delta x tends to 0 delta y upon delta x. Here delta x tends to 0 means that delta x is approaching 0, but it will never reach 0. Here this limit delta x tends to 0 delta y upon delta x can be written as dy by dx or derivative of y with respect to x. Dy by dx represents the slope of the tangent line of the curve at the point xy. Now this is an animated explanation of the whole thing that we have done. Here you can see that both delta y and delta x are reducing and they are approaching this point. Now at this point, can you see the blue line, that is the tangent, and the red line is also becoming the tangent. Let us do a few important differentiation formulas. The first one, d by dx of c is 0, where c is a constant. It means the differentiation of a constant is 0. Let us do a few examples. D by dx of 5 is equal to 0 because 5 is a constant number. D by dx of pi is 0 because pi is also constant. Let's do the second formula. D by dx of cy is equal to c dy by dx. It means that if there is a constant with a variable, then the constant is taken out of differentiation while the variable is differentiated. In this example, you can see 5 is a number. So we take out 5 outside and we differentiate y. That is 5 dy by dx. In this scenario, pi is taken out and we get pi dr by dx. Let's do the most important formula for differentiation that you will be using a lot, which is d by dx of x to the power of n is equal to n x to the power of n minus 1. Now, in this example, n is 5. So what we will get? 5 x to the power of 5 minus 1 using this formula. Or we can write this as 5 x to the power of 4. Let's take another example. D by dx of 7x I need to find. So 7 comes out and we will differentiate x. Now x is having a power 1, that is n is equals to 1. So 1 and x to the power of 1 minus 1 by using this formula again. So that can be written as 7 and x to the power of 0, and as we all know anything to the power of 0 is 1, so it gives me an answer 7. Let's take the third example. D by dx of 4x cube. 4 being a constant comes out and we will differentiate x cube. The differentiation of x cube is 3 x to the power of 3 minus 1, that is 12x square. Let us understand the fourth rule of differentiation, which is for addition and subtraction. This is d by dx of p plus minus of q is equal to dp by dx plus minus of dq by dx. It means if I have got p plus q, I will get dp by dx plus dq by dx, and if I have got p minus q, then I will get dp by dx minus of dq by dx. Here p and q are functions of x. Let us start with our first example. I need to differentiate this term to x to the power of 4 plus x to the power of 5. Now using the rule 4, first we will separate the terms. So d by dx of 2 x to the power of 4 plus d by dx of x to the power of 5. Now 2 being a constant number comes out of differentiation. So what are we getting? We get 2 d by dx of x to the power of 4 plus d by dx of x to the power of 5. Now 2 remains as such, while the differentiation of x to the power of 4 is 4 x to the power of 4 minus 1, and the differentiation of x to the power of 5 is 5 x to the power of 5 minus 1. On solving this, we get 8x cube plus 5x to the power of 4. Let's do another example. Here we need to differentiate x plus under root of x. So first we will separate, that means d by dx of x, which is having power 1, plus d by dx of x to the power of 1 by 2. Now for x we will have 1 comes down and x to the power of 1 minus 1, plus for x to the power of 1 by 2, 1 by 2 comes down and x to the power of 1 by 2 minus 1. In x to the power of 1 by 2 case, n is 1 by 2. On solving this, we get 1 x to the power of 0 plus half x to the power of minus half, which can be written as 1 plus 1 upon 2 under root x. Let us move to the fifth formula, which is d by dx of pq, that is the product part, is equal to p dq by dx plus q dp by dx. This is called as product rule. So we can see one thing. First we took p out of differentiation and differentiated q. Then we took q out of differentiation and differentiated p, and the sign was plus between the two terms. Let us take this example. We need to differentiate x minus 3 into x minus 2. So we will use the product rule. First, we have taken this x minus 3 as p and x minus 2 as q. So what was our thing? P written as such, that is x minus 3, and then the differentiation of q, that is d by dx of x minus 2. Then it was plus, okay, then q written as such, and then the differentiation of p. X minus 3 comes as such. Now the differentiation terms, we will separate them, that is d by dx of x minus d by dx of 2. Similarly, here x minus 2 remains as such, and this will be differentiated. So it will be d by dx of x minus d by dx of 3. Now dx by dx is 1 Here we have taken x to the power of 1, so n is 1, and when we solve we get 1. And the d by dx of 2 is 0 because the differentiation of a constant is 0. Okay, plus x minus 2. Then again 1 minus 0, 1 because dx by dx is 1 and d by dx of 3 is 0. On solving this, we get x minus 3 plus x minus 2, that is 2x minus of 5. Let us move to the sixth one, which is d by dx of p to the power of n is equals to n p to the power of n minus 1 and dp by dx. Here first the whole term, we have considered this p to the power of n as a whole term. So first we differentiated the whole term, and then the base, that is p, is again differentiated with respect to x. This is a very important rule for you. Let us understand this with the help of an example. So we need to differentiate under root of 3x to the power of 4 minus of 5, which can be written as d by dx of 3x to the power of 4 minus 5 whole to the power of 1 by 2. Now here what we can say, that n is 1 by 2 and p is 3x to the power of 4 minus 5. So we will apply this formula. So first we will differentiate this complete term. So 1 by 2 comes down because this is n. Then the base 3x to the power of 4 minus 5, and then n minus 1, that is 1 by 2 minus 1. And then we again differentiate this 3x to the power of 4 minus of 5. So 1 by 2, now 3x to the power of 4 minus 5 to the power of minus half, because 1 by 2 minus 1 is minus half. And now we will differentiate this by first separating the term. So d by dx of 3x to the power of 4 minus d by dx of 5. So this comes as such, and here 3 comes out, and the differentiation of x to the power of 4 is 4, x to the power of 4 minus 1, and the differentiation of 5 is 0 because 5 is a constant. Now on solving this, this is the answer that we will get. Let's take another example. D by dx of 7x plus 2 whole raised to the power of 5. Here n is 5 and p is 7x plus 2. So what we will do, first the power comes down and then the base remains as such, and then power minus of 1, and then d by dx of the base. Okay, so that gives me 5 7x plus 2 to the power of 4, and then we separate. So d by dx of 7x plus d by dx of 2. Okay, so d by dx of x gives 1, because here we can say that 1 x to the power of 1 minus 1, that is x to the power of 0, is equals to 1, and the differentiation of a constant is 0. That's why we got 0 for d by dx of 2. On solving, this is what we get. Let us move to the seventh rule, which is the quotient rule. Here I have d by dx of p by q. So here q comes, then dp by dx minus p dq by dx and whole divided by q square. Let's take an example. So here we have taken p as 5x plus 2 and q as 3x minus 1. We will use the seventh rule. So the thing was, first write q, that is 3x minus 1, then differentiate p, that is d by dx of 5x plus 2, then it was minus, done, and then it was p remain as such, that is 5x plus 2, and differentiate q, that is d by dx of 3x minus 1 divided by 3x minus 1 whole square. Now in denominator it remains same, in numerator 3x minus 1 remains as such. Now we will just expand this term for differentiation, that is 5 comes out, dx by dx plus d by dx of 2. Similarly for second, minus 5x plus 2 remains as such, and we say 3 comes out, d by dx of x minus d by dx of 1. Okay, denominator remains as such, and here it is 3x minus 1, dx by dx is 1, so that gives me 5, and here d by dx of 2 is 0 because it's a constant. minus of 5x plus 2. Here again I will get dx by dx as 1 and d by dx of 1 as 0. So this is what I get 3. On solving, we get minus of 11 upon 3x minus 1 whole square. The eighth formula is d by dx of sine x is cos x. Ninth is d by dx of cos x is minus sine x. And that last one, d by dx of log of x, where the base is e, is 1 by x. Let us recapitulate what we have studied. The formulas: for a constant it is 0. If a constant there were variable, it comes out. D by dx of x to the power of n is n x to the power of n minus 1. Then for plus and minus we did. Then the product rule. Then for p to the power of n, the n comes out n p to the power of n minus 1 dp by dx. Then the quotient rule. Then for sin x it is cos x. For cos x it is minus sin x. And for log it is 1 by x. Now is the time for a few questions. So these are the 5 questions you should try, and here are the answers. Question number 1. Okay, y is given, I need to differentiate it. First I will separate all terms. This is why we have separated. Okay, now in the second one 2 comes out being a number. In third one 5 comes out. Okay, now the differentiation of x to the power of 4 is 4, x to the power of 4 minus 1. For x square it is 2, x to the power of 2 minus 1. For dx by dx it is 1, and for a constant it is 0. Now we will solve this, and this is what we get as an answer. Let's move to the second one. Okay, we need to differentiate this term with respect to x. Okay, we separate the terms. Now a comes out, we will differentiate x square. B comes out, we will differentiate x, and the third one is a constant, so differentiation is 0. Now the differentiation of x square is 2x to the power of 2 minus 1. The differentiation of dx by dx is 1. So the answer is 2ax. The third one, okay, y is equal to under root x plus 1 by under root x. Okay, so it can be written as x to the power of 1 by 2 plus x to the power of minus 1 by 2. We will separate the two terms. Okay, for the first one it is 1 by 2, x to the power of 1 by 2 minus 1. For the second one it is minus of 1 by 2, x to the power of minus 1 by 2 minus 1. We use the third rule of differentiation. Then we will solve them, and this is what we get as our result. The fourth one, this is using the product rule. So this is the product rule for you. Here p is 5x square minus 3 and q is x cube plus 1. So first p comes out and we differentiate q, plus q comes out and we differentiate p. Then we need to separate the terms in p, and we need to separate the terms of differentiation of q. The differentiation of x cube is 3x square. Differentiation of 1 is 0. Okay. Then the differentiation of x square is 2x, and the differentiation of 3 is 0. So this is what we get as an answer. Let's do the last one. Y is equal to 2x plus 3 whole square. So this is the concept of p to the power of n. Here n is 2 and p is 2x plus 3. So first it is 2, then 2x plus 3 to the power of 2 minus 1, and then we will separately differentiate 2x plus 3. We separate 2x and 3. The differentiation of 3 is 0, and the differentiation of x is 1. So on solving this, we get 8x plus 12. Do come for the next video, which is on integration. Thank you.